Numeric literals have the form, and this is again this whole representation. This is just to define numbers, right? This is what makes me not want to make my own programming language. You need to deal with all those rules. Not fun, at least for me. As can be seen in the productions, numeric literals can contain underscores for readability. Integer and floating point literals may be given in decimal, no prefix, binary, prefix OB, octal, prefix OO, and hexadecimal prefix OX notation. The fact that the unary minus in a number literal like -1 is considered to be part of the literal is a late addition to the language. Oh. The rationale is that an expression -128 and 8 should be valid, and without this special case, this would be impossible. Like -128 is not a valid and 8 value. Only -128 is. Okay. For the unary minus rule, there are further restrictions that are not covered in the formal grammar. For the dash to be part of the numeral literal, the immediately preceding character has to be in the set of space, tabulator, new line. Oh, new line, return, comma. This set was designed to cover most cases in a natural manner. This doesn't sound very natural. In the following examples, the -1 is a single token. Echo, -1. Echo this. Oh wait, this is the preceding character has to be in. Oh, so whatever needs to be before the dash. Either the space or parentheses or this guy. Or a comma. Okay, that makes more sense instead of being after. Awesome. And this works as well. Cool. In the following examples, the -1 is parsed as two separate tokens, as a dash and as one. So dash will be in this case an operator. So here we just have a character, so that makes it into minus. We have a closing bracket, so that's why. Same thing here, and this is a quotation mark. Okay, makes sense. All of this suddenly makes much more sense. The suffix starting with an apostrophe is called a type suffix. Oh, this is where crazy stuff is happening, because you can make your own. Literals without a type suffix are of an integer type, unless the literal contains the dot or e, in which case is of type float. This integer type is int if the literal is in the range of low and high of integer. Otherwise, it is int64. For notational convenience, the apostrophe of a type suffix is optional and is not if it is not ambiguous. Only hexadecimal floating point literals with the type suffix can be ambiguous. So we basically, when we specify a value, we can add this kind of thing at the end to specify what kind of type it is, without the need to specify the type specifically. So yeah, this is awesome. And I guess U is just uint, D is for double, S, F is for float, and then we have those separately. Makes sense. Floating point literals may also be in binary, octal, or hexadecimal notation. Seriously, I guess if you want to be as precise as possible, makes sense. Never thought about doing that. I guess there could be a need for that, for a very specific number. Literals must match the data type. For example, 333 as int 8 is an invalid literal. Oh, because it's invalid because this should be at most 127 because it's integer, not even U integer. Non-base 10 literals are used mainly for flags and bit patterns representations, therefore the checking is done on bit width, not on value range. Okay, I'll ignore that.